Hello, in this lecture we will find the values of x and y in this shape. We have a white shape that the area of this white shape equals to 240 units squared, and the width of this white shape equals to 15 units, and the length of this white shape equals to 20 units, and we want to find out the value of x and y. Okay, so first of all we will give names to the vertices of this white shape. We will define this vertex as A, then we will define this vertex as F, and we will define this vertex of this shape as C, and we will define the vertex of this shape at this point as D. Okay, in the second step we will lengthen the segment X to 20 units. We will lengthen the segment X to 20 units. We will lengthen segment X to a length of 20 units, and so actually we lengthen segment X to a length of 20 units as the length of CD segment, and then we will lower perpendicular to CD segment. Okay, we lowered a perpendicular from point, we will define this point as point L. So actually we lowered a perpendicular to CD segment from point L. Again, we actually lengthen segment X to a length of 20 units, and then we lowered a perpendicular to CD segment. Okay, so this angle is 90 degrees. Actually we created here a rectangle because CALDC is a rectangle, because actually the size of AL is 20 units as the size of CD, and they are parallel to each other, and also the size of LD is actually parallel to side AC, and it also equals to 15 units. So actually we built a rectangle, and as you already know, the area of any rectangle equals to the length of the rectangle times the width of the rectangle. Okay, so the formula for the area of any rectangle actually equals to the length of the rectangle times the width of the rectangle. So actually the area of the rectangle ALCD, the area of rectangle ALCD equals to the length of the rectangle, that is actually 20 units, times the width of the rectangle, that is actually 15 units. So 20 times 15 is 300 units squared, or 300 squared units. So the area of rectangle ALCD equals to 300 square units. So I will repeat again. The formula for the area of any rectangle is the length of the rectangle times the width of the rectangle. So the area of rectangle ALCD equals to the length of the rectangle, that is 20 units, times the width of the rectangle, that is 15 units. So 20 times 15 equals to 300. So the area of rectangle ALCD equals to 300 square units. Okay. But we know that the area of the white shape equals to 230 units, 240 units. So actually the area of the rectangle minus the area of the white shape will be equal to the area of this right triangle. Again, the area of the rectangle minus the area of the white shape will be equal to the area of the rectangle, of the right triangle. Triangle FLD is a right triangle because this angle FLD, equals to 90 units. So the right triangle FLD is a right triangle. The green triangle is a right triangle, and again the area of the green right triangle equals to the area of the rectangle minus the area of the white shape. Okay, the area of the rectangle minus the area of the white shape equals to the area of the right green triangle. Okay, so the area of the right green triangle FLD equals to the area of the rectangle, that is 300 square units, minus the area of the white shape, that is 240 units squared. So actually 300 minus 240 equals to 60 units squared. So the area of the right green triangle FLD equals to 60 units squared. Again, I repeat again, the area of the green right triangle equals to the area of the triangle that is 300 units squared minus the area of the white shape that is 240 units squared. So 300 minus 240 equals to 60 units squared. So the area of the green right triangle FLD equals to 60 units squared. Okay. So we know that the area of this right triangle, right green triangle equals to 60 units squared. And now the size of the line segment FN, the size of line segment FL will be equal to 20 units minus X. 20 units minus X will be equal to the area of FL, that is the side of this green right triangle. So I will write it down. FL equals to 20 units minus X. Again, (20 units minus X equals to FL, that is the size of FL, that is the side in the right green triangle. And we also know this is a ALCD is a rectangle, so the two parallel sides are equal to each other. So if this size AC is 15 units, size LD will be also equal to 15 units. Okay, so actually I will draw again the right green triangle FLD. So I draw again the right green triangle FLD. One side of this triangle, one side equals to 15 units, the other side equals to 20 minus X, and the hypotenuse of this right triangle equals to Y. And we also know that the area of this right triangle FLD equals to 60 units. So we actually will use the formula for the area of a triangle in order to find out the value of X. Okay, so actually the formula for the area of any triangle equals to the base of the triangle times the height to the base over 2. Again, the formula for the area of any triangle in the world equals to the base of the triangle times the height to the base divided by 2. Okay? You should remember that the base must create 90 units with the height, or the height must create 90 units with the base. Okay, so the area of the right triangle FLD will be equal to the base of the triangle. The base of this triangle is 20 minus x times the height to the base. The height to the base must create 90 units with the base. So the height to the base is LD. Okay, the height creates 50 units. The height creates 90 degrees with the base. So the height is LD, that equals to 15 units. So the height is 50 units over 2. So in total, the area of this right triangle FLD equals to the base of the triangle, that is 20 minus x, times the height to the base, that is 15 units, over 2. Again, the area of the right triangle FLD equals to the base of the triangle, that is 20 minus x, times the height to the base, that is 15 units, over 2. Okay? So the area of triangle FLD equals to the base of the triangle, that is 20 minus x, times the height to the base, that is 15, over 2. But we have already found that the area of this right triangle equals to 60 units. We have already found that the area of this right triangle equals to 60 units. So instead of the area of triangle FLD, we can write here 60 units squared. Okay, so the area of the right triangle FLD equals to 60 units squared, and it equals to the base of the triangle, that is 20 minus 6, times the height to the base, that is 15, over 2. Now we will multiply equation number 1 by 2. So we multiply the equation number 1 by 2. 60 times 2 is 120. Here we got that 20 minus 6 times 15 times 2 divided by 2 equals to 20 minus 6 times 15. Now we will open the brackets in equation number 1. We'll get that So we open the brackets in equation number 1. 20 times 15 is 300, and x times 15 is 15x. Now we'll subtract 120 from this equation number 1. So we subtracted 120 from equation number 1. 120 minus 120 is 0, and 300 minus 120 is 180. So we got in total that 0 equals to 180 minus 15x. Now we will add 15x to equation number 1. We added 15x to equation number 1. 0 plus 15x equals to 15x, and 180 minus 15x plus 15x equals to 180. We will divide the equation number 1 by 15. So we divided equation number 1 by 15. So 180 over 15 equals to 12. So x equals to 12 units. X equals to 12 units. And now that we know that x equals to 12 units, we also know the size of FL, that is a side in this right triangle. The size of FL is 20 minus x, and x equals to 12 units, so the size of side FL of this right triangle equals to 20 minus 12 is 8 units. Okay. So here you have a right triangle that we know two sides, the size of two sides in this right triangle. We know that FL equals to 8 units and LD equals to 15 units. So we can use the Pythagorean theorem in order to find out the value of y. Again, the Pythagorean theorem states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So y square equals to 15 square plus 8 square. Okay, so that will be our third equation. Again, the square of the hypotenuse is y square equals to the sum of the squares of the perpendiculars equals to 15 square plus 8 square. Okay, so equation number 1 number 3 states that according to the Pythagorean theorem, the square of the hypotenuse, that is y square, equals to the sum of the squares of the perpendiculars, equals to 15 square plus 8 square. 15 square is 225 and 8 square is 64. So I write it down. Again, 1500 is 224 and 15 square is 225 and 8 square is 64. And 225 plus 64 equals to 289. So I write it down. So we got in the first equation that y squared equals to 289. Now we will take a root out of equation number 3. We get that y equals to 17 units. So the square root of 289 equals to 17. So y equals to 17 units, and we have already found out that x equals to 12 units. So the answer to our question is that the value of x is 12 units and the value of y is 17 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the value of x and y, and we have a shape. This white shape, we know that the area of it is 240 units squared. The width of this shape is 15 units and the length of this shape, white shape, is 20 units. And we want to find out the value of x and y of this shape. So in order to find out the value of x and y, we actually created a rectangle by lengthening the size of x to the length of 20 units. So actually we have side AL that equals to side CD, and it also parallel. AL is parallel to CD, and we lowered perpendicular MD to CD segment, and in this way we created a rectangle. All the angles in the rectangle equals to 90 degrees, and we actually know that the area of any rectangle equals to the length of the rectangle times the width of the rectangle. So the area of the rectangle that we created is actually, the length is 20 units times the width, that is 15 units. So the area of the rectangle that we created is 300 square units. And we know that the area of the white shape is 240 units. So the area of the rectangle minus the area of the white shape equals to the area of the green triangle, the green right triangle. So 300 units the area of the rectangle minus the area of the white shape, that is 240 units, equals to 60 units. So we know that the area of the green right rectangle is 60 units. Okay, and actually side FL, or the size of FL, equals to 20 units minus X. So FL equals to 20 minus X. Okay, FL equals to 20 minus X. LD is given us, it equals to 15 units, and Y is something that we have to find. But we know that the area of this right triangle equals to 60 units square. So we can use the formula for the area of a triangle in order to find out the value of X. Because the formula for the area of any triangle equals to the base of the triangle times the height to the base over 2. So the area of this right triangle equals to the base of the triangle, that is 20 minus X, times the height. The height must create 90 units with the base, so LD creates 90 units with FL. So LD is the height of this right triangle. So the height is 15 units, the base is 20 minus X units. So we multiply 20 minus X, that is the base, times the height, that is 15, over 2. And we know, so that is the formula for the area, and we have already know that the area of this right triangle equals to 60 units. So we can create question number 1 that states that the area of this right triangle FLD that equals to 60 units equals to 20 minus X, that is the base of the triangle, times the height of the triangle, that is 15, over 2. And the only variable is X. So we multiply the equation number 1 by 2, we got that 120 equals to 20 minus X times 15, and we actually solved this simple equation with one variable, and we found out that X equals to 12 units. Okay, so X equals to 12 units. So actually we can return to our triangle. Now we know that X equals to 12 units. So the size of FL is 20 minus X. 20 minus X is 20 minus 12, that is 8. So the size of FL is 8 units, the size of LD is 15 units, and the only variable that is left to find out is Y. Okay, so we can use the Pythagorean theorem in order to find out the value of Y. And the Pythagorean theorem states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, and okay, so the square of the hypotenuse is Y square equals to 15 square plus 8 square. 15 square is 225, 8 square is 64. So Y square equals to 225 plus 64. And 225 plus 64 is 289. So Y square equals to 289. So we took a square root from equation number 3, and we found out that the square root of 289 equals to 17 units. So Y equals to 17 units. And we have already found out that X equals to 12 units. So the answer to this question is that X equals to 12 units and Y equals to 17 units. Okay, thank you very much.